Data security of mobile cloud computing on cloud server. Mohammad Wasim, Abdullah Lakhan.
मत पढ़े तो नीचे कर.
Abstract mobile cloud computing या नाम आगा बीच में is a technology of delivering services such as software, hardware, virtual as well, and bandwidth over the internet. Mobile devices are enabled in order to explore, especially smartphones. The mobile cloud computing technology is growing rapidly among the customers and many companies such as Apple, Google, Facebook, and Amazon with rich users. User can access their data at any time, at any place, even with any device, including mobile device, by using the cloud storage services. Although these properties offer flexibility and scalability in controlling data, however, at the same time, it reminds us with new security threats. The security issues can be resolved by proper handling of data. The cloud server provider can secure the data by applying the encryption and decryption techniques while storing the data over the cloud. In this paper, we propose some encryption and decryption methods for securing the data over the cloud so that an unauthorized person or machine cannot access the confidential data owing to encrypted form. Keywords: Amazon Cloud Server, Cloud Computing, Security Data, Data Security, AES, Encryption, Eclipse IDE, JSON API, Share and Cite. Subject area: Cloud Computing, Information and Communication, Security, Privacy and Trust, Mobile Computing System. Introduction. To have an in-depth understanding of mobile cloud computing (MCC), it is necessary to get a complete grasp on cloud computing. Cloud computing is a new market-oriented business model which offers highly quality and low-cost information service. Generally, cloud computing resources are provided in the form of services such as infrastructure as a service, data storage as a service, communication as a service, security as a service, hardware as a service, software as a service, business as a service, and platform as a service. There are various layout architecture available for cloud computing to provide the aforementioned service as a utility. User can consume these services based on SLA, which define their QoS parameters on pay-per-use basis, as well as user can access their data anytime at any place, even with any computing device, including mobile devices. Cloud computing with resource constraint mobile devices, ubiquitous wireless infrastructure, mobile web, and location-based service provides a ground for a new computing paradigm called mobile cloud computing. The ultimate goal of the MCC is to enable execution of rich mobile application on mobile device which are rich user experience according to the consumer and enterprise market. Cloud-based mobile application are expected to rise to $9.4 billion by 2014 due to increase in the number of users. There are numerous challenges exciting in the field of MCC, including data replication, consistency, limited scalability, unreliable availability of a cloud resource, portability, trust, security, and privacy. To attract more potential consumer, the cloud service provider has to target all the security issues to provide a completely secure environment. Many commercial cloud storage services protect user data stored in server storage by introducing client based on or server based data encryption. The objective of this paper is to draw attention to many important issues and challenges concerning with security as well as privacy in mobile cloud application development. This paper also proposes some data encryption and decryption solution for MCC. The rest of the paper is organized as follows. Section 2 presents the research background and overview. Section 3 researches methodology. Section 4 presents the software and tools, and section 5 conclude the paper with a summary of our contribution, research background and overview. The term cloud is used as a symbol of the internet and other communication systems, as well as an idea of the underlying infrastructures involved. Cloud computing commonly referred as the result of an evolution of widespread adoption of virtualization, service-oriented architecture, autonomic and utility computing. The details of location of infrastructure or component devices are unknown to most of the end user. User does not need to thoroughly understand or control the technology infrastructure that supports their computing activities, and the user do not necessarily have their own resources. Following is a brief history of this evolution. Mobile devices such as smartphone, tablets are increasingly becoming an integral part of modern life and culture as the connectivity communication and sharing have turned out to be easier and convenient among people. Mobile application for that matter reduce the performance of tasks in a span of minutes and help deliver accurate result. Today mobile apps are built up not merely for communication but also to learn recreation and to unlike traditional mobile apps such as ringtone editor, grid based games, etc. technology is progressing at a speed rate. Cloud computing service. Cloud service providers offer their services mainly in three different ways, such as software as a service, platform as a service, and infrastructure as a service. Figure 1 describes these three layers of services which are provided by cloud service providers. Infrastructure as a service is mostly offers utility computing, which allows user to get infrastructure from cloud service providers as virtual resource as need basis. Virtual hardware, raw processor, storage software, platform include computers. In spite of having physical hardware in their offices placed in the cloud and information is accessed through the internet. The basic idea behind ICE is not new, but this type of cloud computing is getting new life from big providers like Sun, Amazon, Rackspace. According to architecture showing in figure, IBM and Google, the main benefit in that there is no need to procure a service or execution physical data center equipment like storage, networking, etc. They have organized over the application and operating system they install on top of the rented computing resources. The user cannot handle or control the underlying cloud infrastructure, but it has had power over operating system, deployed application storage, and may be limited the company of us. Figure 1. Cloud architecture provides offline storage server and networking hardware as per rental basis and can be accessed over the cloud. The customers need not to be procure the necessary servers, data center or the network resources. A key advantage here is that clients need to pay only for the time period and they can use the cloud service. Software as a service, SaaS, mostly offer executed application on demand for user. Software execute over the cloud and serve to many end user or client organization. This is the model of software deployment where an application is hosted over the internet and service to the tenants. This way eliminates the need to install and execute the application on the customer own computer. These applications are accessible from various customer devices because of a thin client interface such as a web browser. This type of a service providers complete application to the client which is customizable within the confines. SaaS model service deliver clients prefers cloud-based application from service providers. A SaaS provider cannot store the unencrypted client data. Network-based access and management of commercially offered software there are handled from centralized location and enabling clients to access these application which is remotely over the internet. Research methodology. The paper involves different research approaches. First, a laterally study is conducted to gain a fundamental understanding of cloud computing and usage of its services in the architectural development of software. It also includes research articles of different researchers who have covered data storage techniques and have applied in different areas. Secure data storage by different researchers is also included in the literature study. Next few case studies are also referred in this context, in which we will try to find the pros and cons of different variation conducted and implemented at various organizations, such as encryption algorithms like AES, DES, RSA, Blowfish to ensure the security of data in cloud. The research will be conducted using Java runtime of Google App Engine, JDK 1.6, Eclipse, IDE, Google App Engage SDK, or higher. Following are the steps for purpose work plan. There are many advantages in mobile cloud ecosystem. However, there are some issues and challenges in mobile cloud computing, such as data ownership, privacy and data security, and other security issues. There are some possible solutions are presented for cloud access protection. Strong authentication method ensure that only legitimate user with an authorization can access cloud-based services. Embedded device identity protection. It is possible to embed a personalized configuration profile on each employee's mobile devices, thereby implementing a credential or personal security token on their mobile device. There are some other security features and policies that can be enforced to maximize the security on mobile devices, especially in a corporate context. Security is an important factor in cloud deployment, and by building in the capabilities described in these 6 steps, organization can better manage and protect their customer data over the cloud. The team will also refer to the reports published by EEACM and other renowned research firms. This method will give us the understanding for implementation of mobile cloud computing as point of security view. Software and tool implement secure data storage over the cloud. Endure Google API, Eclipse, JSON, Java, Amazon AWS Cloud Server, unit testing, EC2 Cloud Database, previous work. According to paper, there are many issues in mobile cloud computing due to limitation of mobile devices. Security is the main concern in mobile cloud computing. In mobile cloud computing, data of owner is stored on the cloud, which is not secured. According to paper, due to the feature of resource constraint, security in mobile devices have potential challenges in cloud accessing, consistent accessing, data transmission, and so on. Such challenges can be solved using special application and middleware platform for all mobile cloud computing system. According to paper, the security applying on client side of mobile cloud computing are also inherited in mobile cloud computing with the additional limitation of resource constrained mobile devices such as time consuming. According to paper, mobile cloud computing architecture for code offloading in MCC application addressing both energy and performance issues due to time constraints. According to paper, all processing in MCC perform on the mobile side, so there are some issues related to the data traveling such as bandwidth, latency, availability, and heterogeneity. Key components: DDoS attacks, denial of service in such type attack over the cloud that prevent the client from receiving the service from the cloud. The attacker is continuously attack to the target server to get the server busy, make a machine or network resource unavailable to its intended user, so that clients might not be able to receive the service from the server because server will be busy servicing the attacks. There are many techniques to perform DDoS attacks like SendFloat. The SendFloat exploits the TCP three-way handshake with the help of requesting connection to the target server and ignoring the acknowledgement from the server. Attacker applies attacks to the server. This makes the server to wait for the ACK, wasting time, resource. Eventually, the servers do not have any resource to provide service to the clients. This type of attacks can be prevented by unauthorized strict access to the cloud and many using cryptographic protocol to make sure that the right personnel are accessing the cloud.